Our last graphing is to graph the image y equals 3 times the absolute value of the opposite of x plus 3. And so looking at this, we can say that our parent function is confidently y equals the absolute value of x. So if we go ahead and graph that, our graph should be some variation of this blue line. Now let's see what's going to happen. If we look, we have plus 3. Well, since it's inside that absolute value, it's going to go left to right. A positive number moves it left. And so we're going to take our graph and we're going to go left 3 with it. 1, 2, 3. And let's redraw if we would just move left 3. And there we go, that's in purple. Next, let's look. We have this negative x, opposite of x, inside that parenthesis or inside that absolute value. We're going to reflect it over the y-axis. So currently, we're at the spot negative 3, 0. If we reflect it over our y-axis, we're going to end up at the spot 3, 0. So right here is our new vertex. However, before I regraph this, I'm going to also look and see that our y values are going to stretch by factors of 3. So traditionally, we would have the point 4, 1 right here, where I have an x. However, we need to stretch my y's by 3. So I need to multiply this y by 3. I'm going to end up with the point 4, 3 now. So rather than having a dot at the x, I'm going to go up 3. And I'm going to have a dot here. Same on the other side. I should have a dot at the point 2, 1, where my x is, but I have to stretch my y's by that factor of 3, which is going to give me the point 2, 3. And this happens for the next couple values. So I'm going to go ahead and graph those. And now in red, I have my final function. Right there. A little messy, but it's there. And like I said previously, if you're ever unsure if you graphed correctly, go ahead and plug in values. Sometimes it will make a difference depending on which negation you do first, if you flip it and then shift, or shift then flip. But know that you can always check by plugging in values. Let's plug in our vertex, 3, 0. Does it make it true? If we have y is 0, x is 3, is this a true statement? Negative 3 plus 3 is 0. The absolute value of 0 is 0. 3 times 0, 0. Yes, it is true, so I know my vertex is in the right spot. And it's always a foolproof way to check your work. So the first part of function transformations is seeing an equation and graphing it quickly without having to plot points. And so now we're going to be given a parent function, which we've discussed, and directions, and then we're going to figure out what the equation is going to look like for that new function, that prime function, because that's how you denote them. So we have our parent function, y equals the absolute value of x. To that function, we need to stretch it by a factor of 0.5 in the x direction. We need to move it down 5, and we need to move it left 1. Moves left. And over on the side we have a little cheat sheet for now. So when you rewrite your new function, if we have our parent function is y equals the absolute value of x, When you write your new function, you will call it y prime, or the new function, equals what? So 0.5 in the x direction goes within our parentheses. So we're going to have the absolute value of 0.5x. Left 1 also goes within those parentheses. And we move it left, it's actually going to be a positive number. And down 5 is outside with that negative. And right there is our new function. Same thing with this function. Our parent function is y equals x squared, so we know it's a parabola shape. But let's see how we transform this. So we're going to have y prime equals. We're going to flip it over the x-axis. So we're going to have a negative sign out front. So we're going to have the negative.